So thank you again for making the trip here. Can anyone tell me who the statue is of here? Stevie Ray Vaughan, that's right. This is the music capital of the world. And really the reason that my wife and I moved here over 20 years ago now was because of that. But it's a great town, great city, and certainly a great place for a workshop. Things have changed a little bit over the years, and it has been an interesting ride, which we'll be talking about. But I want to just get to some housekeeping details first. First and foremost, this is not a sales event. What does that mean? There'll be, we have operators, we have technicians, we have some engineers talking about what they have seen in the field, the reality of it. Now, in fairness, the presentations are short, so we're not getting into the details of each of the different case studies, for example. We're focused on data and how data helped in some cases to resolve very difficult or complex problems, and how data has helped us to optimize and innovate as well. So we're kind of looking at one aspect of some of these complicated problems. We are focusing on problems, so don't get the impression that every plant has these kinds of issues and challenges. That's not the case. But it would be boring to focus on the easy challenges, right? So we're really going to get in depth into some more of the those issues that took a while to resolve and had sort of multiple layers to resolving the problems. And we're focused on finding root causes. A lot of times we find where there's a problem, our technicians will work with you, the operators, and we end up solving kind of the effect or the observation, but not getting to the root cause. If you don't get to the root cause, the problem is going to happen again. So this is more about how do you actually get to the root cause of a problem, determine it, resolve it. And then really at the bottom, I had this cool animation of an elephant walking across the screen, but it didn't work out. But I still will address the elephant in the room in terms of, we have innovated over the years and used many different kinds of technologies, membrane technologies, blower technologies, SCADA technologies. With regards to membranes, we started with ESEK type 510, which is still a very, very good product we have installed in many of our plants. And then we've gone all the way through RMRW, the SP, and to the OV. But we really look at things from a system standpoint, and you all know that. So to us, whether you have the RW installed at your plant or whether you have an OV or an SP, is sort of irrelevant. All of this applies to all of our MBR systems. Real quickly on our journey, I don't know if everyone knows that one of our heritage brands or legacy companies, Dor Oliver, was actually the inventor of MBR and had the very first patent in 1966. Then many years later, we kind of took the mantle up again at the direction of Mr. Jim Porteous, who sadly passed away last year. We miss him dearly. But he was always an innovator, a champion for new technology, and he brought over the flat plate Kubota technology to the US and built a team to deliver it. Then in 2004, I mentioned we had our first operator workshop. We've had 10 since then. This is the 11th. In 2012, we made the change from plate to sheet. Again, not criticizing or being critical of the plate. There are many pros and cons to both technologies, but we did see some advantages in going to the sheet, and that is with any technology. And one of the main advantages was that we could get a factory built here in Austin, because we know that in order to evolve the technology, we have to get feedback from you, the operators and the engineers. We have to tell us, hey, this works, this doesn't work, and then we have to have a really quick, good connection to the membrane manufacturer and to the membrane equipment maker so that we can learn and evolve and improve and innovate the technology quickly. That was really the main reason for making that change, aside from some technology points as well. Funny enough, in 2001, we're talking about data today, but in 2001, when I first came on with EnviroEquip at the time, I got a lot of blank stares when I mentioned that we had to create a PNID for a job. Elena, do you remember that at all? Jim said, what? A PNID, Dennis, what are you talking about? And I came from the process industry. Basically, I worked with Motorola, a consulting firm, and that's all you did. When you started a project, if there was going to be automation, you created a PNID, but we really didn't know what that was. We've come a long way since then, right? In 17 years, now we're talking about big data and cloud-based technologies and whatnot. So it's In terms of technology and with particular with regards to data, things have evolved quite quickly. Some milestones over the years, and some of you have been a part of this, many of you have. After 17 years, we have 300 installations treating about 0.2 billion gallons per day of wastewater now. We've had 11 of the operator workshops, and you can see there from the pie chart that we have a lot of different technologies out there in systems. We have a center now, the Knowledge Center, which you'll see tomorrow, and then, of course, the factory. And what I'm most proud of is the team that we have that you all know that services and supports you and our MBR systems. So, okay, MBR has come a long way in 17 years, but still, you know, the 2 MGD there is meant to represent the amount of wastewater that's reused in the US. So it's still about 3% of the total wastewater treatment that's done by MBR. But when you hear people talk about MBR, this has been the same kind of chorus for a long time, it is the technology of today and the future. Going forward, every plant is going to have membranes and in some capacity, and the amount of treatment capacity that is done by membrane bioreactor technology is going to continue to grow. But there are some challenges and some limitations that we have to deal with, and this is kind of a summary of those. From the goals, our personal goals, complete reuse, which we've kind of achieved that, Title 22. Every MBR technology has done that. Full nutrient recovery and delivering energy neutral systems. We're a long way from that. You have to involve multiple technologies in a flow sheet to get to that, which we talked about at WEFTEC a couple of years ago, I think, Elena, if I recall. But we're getting there. Energy's coming down. The technologies are coming into play that we can work into spreadsheets to achieve those goals. We still have some challenges. Operating expenses for MBR can be really expensive, especially if you're not really optimizing the plant, and then all the way down through the limits. Oxygen uptake rate is a limit. We can run at higher solids, it's great, but back in 2004, I think Dr. Diger said, yeah, but the limit is still oxygen uptake. And we've come up with some ways to deal with that, but that's also a work in progress. And then all the way down through sort of reliability in terms of the membranes becoming clogged or other, and peak flows. So to get to the potential of MBR technology, we have to add these other components to the flow sheet to get there. This is an example of some things that we're working on now, from storm flow treatment all the way through ceramic membranes, new fine screening, and of course I show a picture of the factory there. But we also have to get the OpEx cost down. I talked about energy, it's one piece of it. And this is just kind of an example of how far the technology has come just with regards to air scour from 0.76 kilowatt hour per meter cubed. It's kind of a funny unit. But let's say it's about 3,000 kilowatt hours per million gallons, and then all the way down to 0.08. So it's come down remarkably or dramatically through innovation since we started back in 2001. Addressing costs through setting up the factory, which you'll see tomorrow, but that's kind of a separate event. Why we innovate? We have to innovate to address your feedback, and as early as 2003, so our first plant was the Bandon Dunes facility, and Steve, are you here? Steve Major? Supposed to be here, yeah. Steve was supposed to be here. We actually worked on that plant together and kind of designed it together in the back of a napkin on the bullet train in Japan. But then the third plant was running springs, and the operator for that plant is here with us today. He'll be speaking, Trevor Miller, he's in the back. But within several months of getting that plant started up, we had a dewatering event where we had clogging that impacted all the membranes. And we had a team out there, we were cleaning up things. Trevor, you recall, was it a few months after we started up, or maybe it was a year, something like that? And back then I decided, okay, we have to come up with something to address that. So over the years, we've been looking at changing technologies. We've built machines, washing machines to deal with it. And now we think we've got to a design that better addresses that. But that's kind of one of the drivers toward innovation, increasing reliability, efficiency, and other. All the products are good, but again, you try to keep improving and addressing some challenges. But you know, it's great to innovate, but the plants have to work before you can innovate, or after you innovate, I should say. So there needs to be troubleshooting and there needs to be optimization, and that's where all of you come in with your feedback. I'm going to give you a real quick kind of top 10 lessons learned that all apply to the next presentations. We know that sharing knowledge is critical, kind of cliche, but it is. This forum is a good example of that, getting all y'all to share information. With us, we share that with the membrane manufacturer, with Microdyne, and then it comes back around. And that's where we see innovation at the system level and the component level as well rapidly. So we're listening to you. That's why we innovate and why we're obligated to innovate, really, is to take your feedback, do something with it. This is going to come up, I think, in the first presentation, that every plant is unique and site conditions change. From the very beginning, I was saying, okay, and this is really based on some feedback from Kubota, and they had some very good information in the early days that, MBRs probably will be cleaned about 2 times per year, maybe 4 times per year. And that can be the case. But it depends on the plant. It depends on the loading. I mean, we have some plants even with the SP configuration now, Canton. We have some of our customers from Canton here, where we use the SP technology. And because of the site conditions there, they clean more frequently. But it's just, you have to adapt to the site conditions and really address the plant-specific needs in a dynamic way. Maybe winter is different than summer, for example. I mentioned this earlier, we often fix the observed effect, not the root cause. We're trying to change that. It's difficult to do. All the presentations will be geared toward that. That's what we're using data that we collect to help you get to the root cause of problems faster. Process conditions can have a significant impact on MBR performance, and one presentation will deal with that in particular. We call it Up on the Hill, I think. It's the Running Springs presentation. But you can see in the data when the process wasn't right, the permeability wasn't right, the membranes weren't performing right, the process was fixed, the oxygen was increased, the mixing was fixed, and all of a sudden the filterability and the permeability jumped up. I mean, just in lockstep. It was a real good example of how influential or impactful the process can be on hydraulics, and that's still not as well understood as it should be or could be. That's why we need to collect more data and keep sharing knowledge. One of our technicians, Jesse Phillips, this is his favorite topic. Air is often the root cause of operational issues. Bubbles, I guess I should say. Where they end up, they can affect instrumentation, they can affect control, they can affect just about everything. Pipe loss and really wreak havoc on a plant. If it's not addressed, you need to understand it. This is a big one to me that we need to move from reactive to predictive, really, David, what is it, prescriptive? To prescriptive maintenance, where we're predicting what's going to happen. And so we can give you the information that says, hey, filterability is low, you probably want to take a couple steps and bring it back up, and the system can automatically do that at your direction as operators. You get to pick, okay, this is what I want to happen, but that information will be there. And really that logic and computing power as well. Also, we've learned that on-time or real-time online analytics can be really helpful for optimizing systems, especially if you have tight nutrient limits that you're trying to achieve. A lot of things happen on an instantaneous basis in MBR because of the membranes and how filtration works. The design of plants and how we respond to issues for wastewater treatment generally happen on a daily basis. We're thinking in pounds per day, average flows per day, but membranes are reacting instantaneously. That's why we have to make sure that fluxes, for example, are at the right points, the right set points, to handle those daily flows. And also that all of the process set points are making sense for the diurnal changes in flow and loading. Online real-time analytics can help us to do that. It doesn't make sense in every case, but you'll see a couple of examples where it was sort of a game changer. We launched the fishbone concept really with Kubota, in fairness, years ago, about 2011, 2012. First started kind of using it at the Alderwood plant. We were doing some work there, some optimization work and troubleshooting. And the fishbone concept itself is not unique to this industry or to this application. But what it is kind of a static troubleshooting guide. Go through these steps to get to the solution. We're trying to move past that because it's kind of static. I said dead, but it's really static. If we get data and feedback from you in a certain format and we put it into a database and then we link what you see to the root cause, the next time you call us and you say, Eddie, turbidity's high in the turbidimeter at the plant here, what is it? And he'll probably just know off the top of his head, but he can look it up and eventually you can look it up, and 33% of the time it's air. 25% of the time the meter's not calibrated. But at least kind of give you living map of how to fix a problem. With all this, I'm talking about data. And data is great, but it has to be in the right context, and that's what's really difficult to do. That's what we've learned anyway. We have massive amounts of information. We have terabytes of data on our servers, but trying to put all that into a context that can help you in the field is difficult at times. Sometimes it feels like we're starting from scratch, except for, of course, the technicians and you that have the knowledge and experience in your brains, but in terms of our documentation and making all that accessible, it's difficult to do. So the focus here is putting data in the right context so we can help MBR reach its potential. Data, 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 can't make bricks without clay. What kinds of data are we talking about? Quantitative and qualitative. So what you see in the field is important as an operator. The data that you get from your processor is important. All of it can be combined together to solve problems. Here are some examples now. I mean, temperature and worms, scanning electron microscope image of a membrane surface, roll patterns, all of that counts as data. We'll be talking about that next couple days. And this is the golden rule, number 10, that behind every good plant, every good operating plant, there's a good operator, a trained operator, and technician in some cases, armed with good data, and that's really the focus of this workshop.